Okay, as I was just mentioning, I'm going to go ahead and get that day built, and I'll put it in today so I can post the video from today. But we don't have a day in the schedule for today, so we're going to come down and pick up the file that we need for today's examples from February 22nd. And while you're getting that and getting it unlocked and getting it open, I'm going to introduce today's topic, which is the idea of an array or arrays. So just so I can kind of see where you are so far, how many of you can say, oh yeah, I already can use arrays? Oh, about half? I know I can. I mean, every time I get a paycheck, I look at it and I say, boy, I sure can use arrays. There's not that many jokes here. You got to take what you can get. So somehow in the world of computer programming, we talk about an array as if it's enough to say an array. But array is a word in the English language. Like I could say, we use it. In fact, there's a hymn, Hope of Israel, rise and might, with the sword of truth and might, sound the war cry, watch and pray, vanquish every force. I don't know, somewhere in that song it says, and the battle's in array. I mean, like the word array shows up in that hymn. It's a word in the English language. What does it mean? What does the word array mean just in English? Someone look it up on Google. Find me a definition for array, A-R-R-A-Y. And if you pick the right one, you'll get a gold star for the day. Just someone look it up and tell me what it means. Yeah, go ahead. An ordered series or arrangement. I like it. That's excellent. That's right, an array. I could look, I could, in fact, does it make sense for me just to gaze upon this room and say, my, what a beautiful array I see? Does that make sense? Ah, it's an array of something. It doesn't make sense to say an array. It's an array of something. Say it again. Yeah. Are you, tell me your name. Oh, Tanner, you're my TA. I can't quite see you back there. Not TA for this class, TA for a different class. Tanner, thank you. I'm going to plug in, don't lose that, because I'm probably going to ask you a couple more times to repeat that definition for us. So it's an ordered arrangement, but it's always an ordered arrangement of something. And so somehow in computer lingo, when we talk about it, we say, oh, it's an array, but it doesn't make sense to say an array because an array is an array of something. If I say, what a beautiful array here I see, I'm going to say, what a beautiful array of students, or a beautiful array of chairs, or a beautiful array of steps, or a beautiful array of acoustic paneling pieces here on the side. And so in the world of programming, when we say an array, it's also an array of something. And I think it will help us if we actually understand. I start off by understanding what it's an array of. And so I'm going to let you kind of think about that for a second while I tell you the story of my very first experience working with arrays in the world of programming. When I was about 10 or 11, let's see, it was 1979. So I was 11 years old. We were visiting my uncle who lives in Salt Lake. I was raised in Southern California. And we would often, my mother was a school teacher, and so we would often go places during the summer. And one summer we were visiting Uncle Jim in Salt Lake. He lived on 2nd Avenue in Salt Lake. Big, huge Victorian home. And he actually had it split up to 3 different units. So he had a couple of apartments, and then he lived in the main ground floor unit. One morning, I was sleeping in the basement. My father came in and he opened the door to where I was sleeping. He said, son, the house is on fire, and the fire department has asked us to evacuate. I need to know the fire department has, do I need more than the house is on fire, please evacuate? But it's I'm going to tell you the fire department has asked us to evacuate. I'm not quite sure exactly why he said. That's what he said. Kind of some things stick in your mind. The fire department has asked us to evacuate. My father was not a practical joker. There was no chance that he was making this up in my mind. And so great, I put on some shoes and I got out. And sure enough, fire trucks, they were spraying water on the house and everything. It wasn't like the top, someone fell asleep smoking in the top apartment, and it wasn't, there was way more damage done by the water than there was done by the fire to the home. My father's a general contractor, and my uncle, a computer programmer, brilliant, owner of a Silicon Valley startup company. I don't know if it was a startup at that time, probably even larger than startup. And so my uncle hired my father to remediate the fire and water damage on his home. And as part of the payment, he taught my father to program. So as a result, kind of like in the late 70s, early 80s, like at my home in San Diego, we had like serious computing power of the time, like commercial grade computers. My fellow students had like you wouldn't recognize these, but the Commodore 64, the VIC-20, these were like the home computers of the early 1980s. And so I was like really fortunate to kind of get exposure to like real computing stuff at that early age. And I remember the day my father tried to teach me the stuff I'm going to teach you today. All right, I'm going to teach you what an array is, son. Sit down, son. I'm going to teach you what an array is. And he started to use a metaphor. He said, arrays are like post office boxes. Now, when I say post office box, what image comes to your mind? Like when I say post office box? What's that? Big blue ones. Oh, like the ones on the corner. Yeah, like the place where you might drop letters. Yeah, okay, good. Rural San Diego postal box images. Let's see if we can find what. Oh, wow, there's not that many pictures here. This is probably the closest one. This is what I grew up with as post office boxes. Yeah, this is actually a really good picture. This is what, in my experience, what a post office box was. Now, what he was thinking when he said that is he was thinking this. Oops. He's thinking these. So he's thinking, and you say, Tanner, what's an array again? An ordered series or an arrangement. This is what he's trying to evoke in my mind as an ordered series or arrangement. And what am I thinking? I'm thinking this. And we probably spent an hour trying to get the point across. And I wasn't getting it at all. I said, okay, forget about the post office boxes. And he said pigeonholes. Now I knew a pigeon was a bird, and I figured birds like made nests, or I've even seen like some kind of bird that like burrows into a cactus, makes a hole in like a saguaro cactus. That could be like what a pigeonhole is. But I guess like pigeonholes that are kind of arranged, kind of like those post office boxes, an orderly arrangement of things. After about an hour of that, I was in tears. I couldn't understand it. I had no idea what he was talking about, and I thought I just must be a moron. And I was in tears. By that time, my father was in tears. He thinks my son must be a moron, and we gave up. I did not learn what an array was that day, and part of the problem is that I never grasped that it was an array of something. It was an orderly arrangement of something. And in VBA, when we say an array, the part that we are leaving off is of variables. When we say an array, we are talking about an array of variables. It is say it again, Tanner. Boom. An ordered series or arrangement of variables. And so when we create an array, what we're doing is we are creating a truckload of variables all at once. Let's just take a look. I'll kind of get introduced to the idea, and then we'll look at the problem that we're going to try to solve today. So let me just make a sub-procedure here, and I'm going to call this sub-procedure initialize. Dim hotel as string. Okay, this is not a trick question. What does that line do? What does that line create? Like that statement is going to create a variable. The variable is of type string, and the name of the variable is hotel. And hotel. And how many variables did I just create? One. Now, I'm going to make a bunch of hotels all at once, a bunch of hotel variables all at once. by putting in parentheses after the name of the variable a number. All I did was add in parentheses 100 after the word hotel. And now this very same statement does not create a variable. It creates an array of variables. How many variables have I created now? That's a trick question. It's not 100. How many is it? 101. Because arrays start counting, by default, they start counting at 0. And the reason is, because remember that what a variable is just a nickname for a location in memory. There's like someplace in memory, right there, that spot in memory, and I'm going to give that a name. And so when I declare a variable called hotel, I'm saying that location in memory is called hotel. The number now that comes off of that, let's say for a moment it's an integer variable, not a string, because integer variable is fixed width. It's a little bit easier to think about. When I make an integer, I allocate how much memory? 2 bytes of memory. And so if I would declare hotel as an integer, that location in memory is called hotel for my purposes, and it's the next 2 bytes that we're talking about. When I create an array of, say, 10 variables, then instead of allocating 2 bytes, I'm allocating 20 bytes, so I can have 20 different 2-byte variables. But the name still points to the very first part. And the number then is going to refer to as a number of bytes to offset, or I should say a number of variable sizes to offset. And so the number that comes after it refers to how far I have to offset from where the variable starts in memory, or for where this array starts in memory. So now, if I was to put a value into this, I can't just say hotel equals like I would if it was a variable. Right? If it was just a regular variable, I could say hotel equals the Sheraton. The Sheraton in Salt Lake City. Salt Lake City. If it was just a regular variable, that's exactly what I would do, right? Put its value in. But because it's an array, I have to say, of all those 101 variables, which one do I want? I'm going to say I want the very first one, 0. I'm saying go to that location in memory and offset how many times the size of my variable? The answer is 0. Right there, that's the first one. If I'm going to go to the next one over, I'm going to offset 1 size from where the starting point is. So that's the reason that it starts at 0. The truth is, in most programming languages that implement an array, they start counting at 0. This is kind of normal. But that's what an array is. And so I can now, I got 101 variables. Let's lower things down. I got 10 variables. I'll go ahead and write 3 of them in. Oh, here's one, the W. There's a hotel called W in New Orleans. Any of you ever stayed at the W? There's a few of them in the country. No? And we might as well do a Marriott somewhere. Marriott in Phoenix. And that should be hotel. Let's make this hotel number 0, hotel number 1, hotel number 2. And then I could print those off. And of course, if I just said I was going to print hotel 1, hotel 2, and hotel 3, immediately we'd see that these like variables are like set up now for me to be able to use a loop. This is what makes arrays powerful, is I can refer to the different variables in the array. I don't have to use a full name. I can refer to them by a name and a number. So if I dim x as an integer, and then I loop here, I make a loop here that says for x equals 0 to 2, next x, then when I run this, that's going to print off all 3 of those names, because it'll set up those values in the array. And then the first time through, we're going to say, oh, we're going to print out what's in the hotel array. Which element of that array? The number 0 element. Next time through, x will be 1 larger. It'll print the number 1 element. Next time through, the number 2 element. It's this idea that allows me to say I've got a variable, but part of that variable is identified by any expression that can bring back the right number for the element in there, that the array becomes powerful. Because now I could say, I've got all these hotels and I want to do the same thing to them. Great, put them in a loop, make an index that goes across all of them, and I can do it all without having to write every single variable out. This is the big difference. I don't have to declare them one at a time. I can declare them all at once, and I can treat them uniformly. Okay, show me how comfortable you are with the idea of an array. This is just the beginning of array. And so right now you're saying, hey, okay, 4 or 5. That looks good. All right, let's talk about the problem that we're going to solve. So this data comes from the Starwood Corporation. And I think I swiped it off the internet, and I think there's a couple of errors in here, which I probably should fix, but I've just never gotten around to fixing them. Like one of these is clearly somewhere in Canada, and it's like its address puts it somewhere here on the West Coast. We'll probably bump into it today. So, so these are not all the hotels that are owned by the Sheraton Corporation in the Western United States, but it's like 35 of them. 36 of them. And then what we have here is the distances between these two. So if I was curious to see what's the distance between this one that we have here in hotel number 1 in Salt Lake City and say hotel number 7 in Las Vegas, about how far is it from Salt Lake City to Las Vegas? Anyone know? About 600 miles. Yeah, I think you're close there. So that's what this table tells us. And so this is between hotel 7 and hotel 1, hotel 7 and hotel 1. That's saying it's 425 miles. I was thinking it was more like it was longer too. Let me just see. I wrote this table, so I could have done it wrong. SLC to Las Vegas. It's like telling me how to fly there. 420 miles. So yeah, I think it's about 6 hours to drive it. But anyway, it's 420 miles. And that's what we say here, 425 between those two properties. It's actually from the street address from one hotel to the other hotel. And so this data shows us like what's the road distance between all of these. And if we look at this, it's going to tell us that the distance between hotel number 7 and hotel number 1 is the same as the distance between hotel number 1 and hotel number 7, 425. So the diagonal has nothing in it because that's the distance between hotel number 3 and hotel number 3. Like it's 0. It's going to like the same place. Quite often, like if you look at a map that has this on, it'll have miles on the top half of the diagonal and kilograms kilometers on the bottom half of the diagonal. And so here's the situation. Suppose that you have been hired or you got your internship. Let's say you've been hired by the Southwood Corporation. You're going to come and work in their regional office, their Western regional office, in the hospitality industry. And your supervisor says, we're so glad that you've been hired here. No one knows you work for us yet. No one. And so here's what I want you to do. I've got this list of 35 hotels. Some of these hotels are really knocking it out of the park. Some of these hotels are struggling. Here's what I want you to do. I want you to go, before you show up for work, like your first 3 months, you're going to go and visit every one of these hotels. And you're saying, that's kind of a hardship because I've got a family and I've got kids. No problem. We're going to rent a van for you. You can take the family and just go. We'll give you the corporate credit card. So you'll just go, you'll check in, you'll pay with a credit card, and we want you to do everything. So, eat at the restaurants, spend some time with whatever personal trainer they might have there. Definitely spend some time with the masseuse there. Okay, so you're all right. This is my job. First part of my job is traveling around the Western United States. I got to go to these 35 different properties, take notes about how they're doing and like what we can learn from the good ones and what we ought to not do from the bad ones. So, maybe not your favorite assignment, but that's your assignment. So you say, great, well, what order should I go to these properties in? And what does your new boss say? I don't care. Just go to all of them. So you're going to have to figure out like which one to go to first, which one to go to next, and so forth. Now, if you were to describe like the characteristic of the best route you could come up with, what would that characteristic be? Like the route I'm going to choose is the one that, yeah, go ahead. I thought, I want to minimize the distance traveled. The reason is every minute in the van with the kids is one less minute with the masseuse, right? So I want to minimize the amount of time that I'm traveling. All right, how are you going to do it? What are your thoughts? How could we, we got a great computer up here. How could we figure out what the best route to go is? I will get you started. We're going to start in Salt Lake City. I'll tell you one. The closest one to where we are right now is in Salt Lake City. So we're going to start at that #1 property, which is in Salt Lake. And then what? Or how do we do it? Can we come up with an algorithm that we could code into VBA that would pick the best route? And if so, what does that algorithm look like? Step 1 is go to Salt Lake City. How do we figure out where to go next? So we'll go to Salt Lake and we'll say, let's start at Salt Lake, and then we'll find what's closest to Salt Lake. The answer is Las Vegas. That's why we did those two to start with. And then from there, we'll say, what's closest to Las Vegas? Guess what the answer is? Salt Lake is the next one. So it's not just who's the closest, but it's who's the closest that we haven't been to yet. So that'll take us to Las Vegas. And then from there, it'll take us down to I think to San Diego. No, to take us into Los Angeles. And that's a pretty good algorithm. What I like about that algorithm is it's one that's not, it's easy to explain. It's not too difficult to calculate. It is virtually guaranteed not to give us the shortest route. In fact, some of you probably recognize this problem. What's the name of this problem? This is a famous problem. What's it called? It's the traveling salesman problem. And we've been studying this problem since the 1700s. Like, mathematicians have dedicated their careers to solve this problem. And there's only one known solution. There's only one known algorithm that is guaranteed to give you the shortest route. Can you imagine that? We've been working on this problem for hundreds of years. Really smart people have spent their careers, and we only know one way to calculate it. And I bet you can figure out what that way is. Count all possible routes, calculate all the possible routes, and pick the shortest one. That is the only known way to do it. And when I first thought, hey, this would be a pretty good example for dealing with arrays. I was a professor still at Tulane University back in New Orleans. Did I tell you that was my first professorship at Tulane? I was there until Hurricane Katrina. That was a neat experience. So I thought, I'll just calculate, I'll write an algorithm to calculate every possible route. I had never really had been exposed to the traveling salesman problem in the past, and I thought this would be interesting. So I'm almost surprised that someone can tell me how many routes there are. Like, don't give me the number, but how do you know how many routes there are? There are 35 properties. What's the total number of routes? Say it again. It's not quite 35 to the 35th. 35 factorial. So 35 times 34 times 31. And that doesn't seem too bad. Fortunately, we got a function in Excel called factorial, F-A-C-T, 35. That's how many routes I'm going to have to calculate. Now, the truth is, when I got this algorithm to calculate, I thought this is probably going to take a little while to calculate because I knew it was a pretty big number. And so I set it to calculate, and I went home. And I came back the next day, and it was still calculating. And I thought, I better figure out how long it's going to take to calculate. So here's the number. That is a number that I don't know. I was never good with scientific notation. What does that mean? Let me put it as like commas. We can take off the. That's how many routes there are. Let's see. That's 1,000, million, billion, trillion, quadrillion, quintillion, sextillion, septillion, octillion, nonillion. I'm done. I don't know. I don't even know what that number is called. There's a lot. And I thought, well, I don't need this computer, I got other computers, so I'll just let this computer run. And I found out that it could calculate. I said, well, I wonder how many it can calculate, like in a second. And I found out that it could. I was pretty surprised. This was like early 2000s. It could calculate 5,000 routes per second. I thought, oh, not bad. So I'm going to reduce that. I'm going to tell you how many seconds that is, and divide that by 5,000. That's a lot of seconds, but I don't think I still have a grip on it. I'm going to divide it by minutes. or tell you how many minutes it is. Take that, divide it by 60. Take this, divide it by 60. Take this, divide it by 60 again. That's hours. Take this, divide it by 24. That's days. I'm starting to get a feeling for it, but I still don't even know what that number is called. 366, we're going to round up. That's how many years it would take. And at that point, I realized that's probably not going to happen. I don't think it's going to happen. But it was like, at that time, I was like, I just read like in PC Magazine, like the 1 billionth computer PC had been produced. And I thought, what would it take if we like dedicated all of humanity's processing power? And I thought, you know what, 1 billion computers, that's probably going to take care of the problem. But that would be like, you know, a lot of those are out of service, but then a lot of them are more powerful than this one. So let's just, as an estimate, let's say that the total processing power of humanity is 1 billion times this. Divide that by 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. Like if we put every computer that we have to solve this one problem, it's, I don't even know what that number is. How long has the universe been around? Like best scientific estimates for the age of the universe? We don't have any like, you know, guys from the science school over here? Yeah, about 14 billion years. That's really good. Like 14, between 14 and 20. 14, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's a number I can say. That is hundreds, thousands, millions, billions. If we were to dedicate the full processing capacity of humanity to solve this problem, it would take 4 billion times as long as the universe has existed to solve the problem. Or I should say, to be sure that we have found the shortest route. Literally, that is the only known algorithm guaranteed to give this the shortest route. Like, so what do mathematicians spend their time doing? They're like, you know what, like 99% certainty, we can say that we've thrown away like 80% of this problem. Like with 99% certainty, we can ignore these and focus on this. So they try to figure out algorithms for that. So the interesting thing about this problem is that, folks, you could pick the worst route and you could drive it dramatically faster than you could calculate the fastest route. Like dramatically faster, right? Like you could do that in your lifetime. That's pretty fast. So like getting to the true shortest route is not going to happen. And in fact, like you could do way better by just looking at a map and a pencil and going, why don't we go this way? Yeah, that's going to be a pretty good route. So here's my plan. What we're going to do is we're going to use arrays. We're going to get familiar with arrays. And we are going to solve this using the next nearest hotel algorithm. That is, start somewhere and then say, what's the closest one we haven't been to, until we get there. And then when we see what that generates, and we won't be generating it until next Monday. We won't get to it, the problem that far. You're going to look at that and say, you know, hey, this is pretty good. And get to the end, you went, yeah, this is a bad route. So the fun part about this is we're going to make Excel pick a route that's a reasonable route automatically. The dissatisfying part about it is, you know what, you could have done better with a pencil and a map, like really better. But imagine a company like FedEx. Like FedEx has to solve this problem thousands and thousands and thousands of times a day. And so like they've got to have some algorithm to be able to do it. And only for them, it's more complex. Why is it more complex? Well, yeah, more stops. Like for each time, they've got to do more stops. That doesn't make it more complex. It just makes the problem bigger. It's more complex because a left turn for FedEx is dramatically more expensive than a right turn. Left turn takes longer to do, and there's a much higher likelihood of getting in an accident when you're turning across traffic than when you're not turning on traffic. And so, you know, trying to pick the best route isn't just the shortest route. It's like shortest, but also balance that against safest and also balance that against fuel consumption. So, yeah, so they got to have, you know, ways to come up with this. You can't, like FedEx doesn't have the luxury of doing this with a pencil and a paper every day, right? They've got to automate that process. So, and that's why mathematicians can spend their careers on it, is like, you know, finding something that's 5% better than we used to do is going to save millions probably millions a year for a company like Federal Express. Okay, so here's the idea. What I've done here on this sheet is I have built kind of a representation of that first array that we built, the hotel array. So you remember that each element or each variable in that array has an index number to say which one it is, and then we've got the value here. Now, we're not going to actually be like even reading the data off the sheet or writing to the sheet. This is just a way for us to think about and look at what does that array look like. Now, the truth is, in memory, the array starts at a location, and then it's one long contiguous stream. But we can think of it as kind of being this grid here. That will be helpful. So let's go ahead and get this part built, and we're going to use this distance array. We're going to use this array is like the way the data comes to us, and we're going to read the hotel names off of this array. So let's go ahead and get started with that. All right, so I'm going to declare this. I've got 36 hotels to put in here. So what number do I put here? 35. That'll give me 36 variables, numbers 0 through 35. I've already got X declared here. And let's, instead of hard coding those, let's go ahead and say for X equals 0 to 35 across the whole part of the array. And let's, instead of printing out what's in here, let's say hotel sub X equals, and then we'll read it off of that sheet. Now that sheet is called distance. So distance will be the name of our worksheet. Looking at the distance sheet, we want row number. Let's do, I think it's easier for me to think of reading down. And so the row is going to change. So I want some row, but distance not cells, some row. I'm going to skip the row for a moment. And I'm going to put in column 1. I'm looking at column 1. And I want the value. So I'm going to read the value off that first column, but how do I tell which row that I want to pull the data from? If I look over here, it looks like my first one is in row number 2, and then it counts down from there. So what expression do I put here so that when this runs, the first time I get 2, then 3, then 4, what do I put here? Yeah, 2 plus X or X plus 2, either one. And so when I'm writing to the number 0 spot of the array, I'm reading off of column 1, row 2. And then when I'm writing to the number 1 spot of the array, I'm reading from row 3. That looks great. And I'm just going to put a separate loop. Oh, I should have copied this before I changed it, because it's exactly what we used to have. And we'll just print that off. Okay, so now when I run this, it's going to first read all those values into the array, and then it's going to scan that array again to print them all out. And probably should print X as well here, just so we see the index number and we see the value there. So our last one is Sheridan Sana's Hotel. Ho, ho, ho. Is that the last one? Yeah. Sana. It's hard to say without thinking of the jolly old elf. Okay. So we've built that array. We've populated it with values that we've read off of the worksheet. Okay, we're going to make a new step here. And so far, everything we've done with variables, these variables have been what we refer to as local variables, declared inside of a subprocedure. We declare a variable inside of a subprocedure. It is only accessible from inside the subprocedure. But I'm going to want to have this subprocedure that initializes my arrays and a different one that like calculates the distance between hotels. And I want them both to be able to refer to that same array. And so what I'm going to do is I'm going to declare these variables somewhere else. Instead of declaring them here, I'm going to declare them here. It's the first time that we've seen that you can declare a variable outside of an array. So up here at the very top of the module, after any options that I've specified, I can declare variables that now have a different scope. That means that these variables now are available to be accessed from any subprocedure in this module. This variable has module scope. if I wanted to make it available to any procedure in any module, I don't use the keyword dim, I use the keyword public. That makes a global variable, one that's accessible from anywhere. So we have those three levels of scope: local, module level, and global. It would work to leave it as public, but I only have one module here, so I'm going to go ahead and leave it as dim here, which will just make it available to anything inside this module. Now, the second thing that I would like to do in this example is kind of make arrays a little bit more complex for us, and that's this. Let's suppose that I'm not just solving this problem, but I'm going to have to solve this kind of on several different sheets. Sometimes I've got 35 properties. Sometimes I've got 22 properties. Sometimes I've got 80 properties. And so I don't know going into it how many hotels I want. I want to be able to ask how many hotels there are. And then from there, I want to declare the array to be that size. Now, here's the problem. When we declare a variable, the variables are, even though we can put the dim statement anywhere inside the subprocedure, that variable, all those dim statements are processed before the procedure starts to run. When we say we want to run that procedure, the interpreter says, okay, great, you're going to run the procedure. I better allocate the memory that you're going to need in this procedure. And step one, it goes through and finds all the dim statements, and it allocates the memory that you've asked for. And then it starts running. So what that means is that we can't ask how big we want the array to be and then declare the array, because by that time the dim has already been processed. And so the good folks who wrote VBA have anticipated this problem. And so they said, well, you can make a static array the way you've done it here if you know exactly how big it needs to be, or you can make it a dynamic array. The way you make a dynamic array is by taking these numbers out of the parentheses. You just open and closing parentheses. What you're saying is to the interpreter is get ready to make me an array. And the interpreter is like, well, how many elements, how many variables do you want in the array? And what do you say? I will tell you how many to make when I am good and ready. You just get ready to do it. That's what you're saying. So great. I'll make an array. You can't use it until you really tell me how many there are. And so this dynamic array now is one that can change size while the program is running. And that's the way that we do it. We say we do the same thing. We just don't tell it how many variables to make. Later in my code, then, I can come down here, and instead of dimming it, I'm going to, this is great, I'm going to redim it. I'm going to redimension that array. I'm going to give it the name of the array, hotel. And then in the parentheses, I'm going to say how many I want to have. But the nice thing about this is that this now can be any expression because the redim happens after the procedure starts running. So now I can actually calculate that out. So let's just go ahead and do that. Instead of putting 35, let's put an expression that figures that out. And I'm just going to do this. I'm going to do hotel, redim hotel, distance, cells, row 2, column 1. That's my very first one there. And from there, instead of asking for the value, I'm going to say end, move down, XL down. Just go down to the end of the contiguous data. I'm assuming that the set of data here is going to be contiguous. I'm assuming there's more than one, and it's going to be contiguous for this to work. I think those are pretty good assumptions. That's going to give me a reference to the very last cell. And so I'm going to ask for the row of that. Now, I want this ultimately to be 35. So let me just see where I am down here. That's on row 37. Oh, yeah. So I have to subtract off the one from the top that's blank. And then to get from a one-based counting system to a zero-based counting system, I got to subtract 2 off of this. And so I'm going to subtract 2. So I'm going to redim this, but I'm going to have it pull. I'm going to have it figure out how big to redim it. This now should behave the same way. If I run this again, it should print off exactly the same thing. Because I'm doing the same thing, except I'm telling it to figure out how big to make the array and to use it. So we've made arrays a little bit more complicated by making them dynamic instead of just static. Show me where you are, 0 to 5. Still some 5s. You're feeling pretty good about it. Okay, so it's a little more involved, but conceptually it's not too bad. Okay. So at this point, we've built our hotel array. Like the first array that we're trying to build here's the arrays that we're hoping to create, is the hotel array. Now, how should we think about building like our answer? Like we're gonna have to put these hotels into a sequence. We're gonna say, this is the first one you go to, here's the second one you go to, here's the third one you go to. How should we do that? We could write it onto a worksheet, but we're trying to get some exercise using arrays. So let's make an array. And what type should that array be? What kind of data should that array hold? This is gonna be the array that's telling us the order that we're gonna go to these hotels. Go ahead. Oh, why not strings? You think integers is better? Oh yeah, so what we've done by building this array right here is we've just given a number to each one of those hotels, 0 through 35. And so if we make another array called route that has the same number of elements, instead of writing the names of the hotels in here, we could put just the index number. In fact, what would we do here? Our first one, what would we say? Yeah, we put a 1 there. It's not because it's the first one. It's the first one because it's in the very top slot. The 1 means what? Yeah, it's the number for the Salt Lake 1. That's where we're going to start. And we already told you that where we're headed next is Las Vegas. And so what are we going to put in here? 7. Now, we're not putting it on the worksheet. The worksheet is just so that we have a way to think of the array. We can look at the array and think, that's what we're dealing with. And in fact, you remember that the problem is going to be here that when we go to Las Vegas and we say who's next, it's going to say go back to Salt Lake. So we need some mechanism to be able to tell us, have we already been to the hotel that we're considering going to? How could the route array help us with that? How can we use the route array to say, have we been there? Go ahead. Okay, so maybe instead of maybe we could make another array just called been there. It's the same size and we put true or false. We could do that. I don't want to do that. I want to look at the route array. I want some algorithm that lets me look at the route array and decides, have I been there? Go ahead. Yeah, so what I would do is just say, hey, look across the array and say, have I'm trying to find, have I been to hotel number 1? I'm in Las Vegas. Who's the closest city? Hotel number 1 is the closest hotel. And before I choose that as my next place, I'm going to say, well, wait a minute, have I been there? And so I can say, look across the array and see if the 1 is in there. And it will go, yep, the 1 is in there. It'll do through the loop. We'll get, oh, it's there. We're done. Return true. We've been there. Okay, good. When I was first solving this problem for years, I did exactly what you suggested. Just made another array called been there and put true or false in it. But this way gives us kind of a little more exercise of using an array rather than just writing to it and reading out of it. But there's a little bit of a problem here because of the default value that variables get. If we make this an integer, and that's pretty good. I mean, we could get by with byte because byte is 0 to 255. But I can imagine myself wanting to solve a problem that's larger than 255. I might imagine myself trying to solve a problem that's larger than 32,000. Maybe we should use long. But whatever one we type, whether we choose byte, integer, or long, we have a problem with the default value. This looks blank here, but it's not really blank when we create it. What does this look like? Yeah, it's full of zeros. Why is that a problem? Because one of my hotels is 0. And so if I leave this with zeros, at some point, I'm going to say, hey, the next closest one is this one in Los Angeles, number 0. Have you been there? And what's it going to say? Yeah, you've been there. So maybe what we should do when we first create our route is we should put some number in there that we are sure is not one of our hotel numbers. Doesn't matter which one it is, but anyone that we're not going to accidentally ask if we've been there to one of our valid hotels. So what should we put in? Go ahead. Okay, yeah, so we got 35. We can put 36. We're only ever going to look at 0 to 35, and so eventually we'll write over all the 36s, and that would work beautifully. There's a simpler way to do it. Doesn't involve. That's not very hard. We've already calculated how many it is, so we could just do it pretty easily. But there's a simpler way. What is it? Go ahead. Any negative number, like -1 would be great because the smallest we can have for our array is going to be 0. So why don't we start off by saying, let's go ahead and declare the route array, and let's fill it up with a bunch of negative ones. So I think I'm going to need the route as well. So let me just go ahead and like duplicate this, but instead of calling it hotel, calling it route. And when I redim the hotel, I'm going to redim the route the same way. But you know what? This is kind of ugly. It's like a long, if I'm going to have this a bunch of times, maybe I should put that into a variable and use it differently. Or it turns out, let me just put 5 there for now, and let me put a breakpoint here and run this. It turns out that I can ask how big an array is. There's a function built into VBA called upper bound, ubound. And I put the name of the array, hotel, and it will tell me the upper boundary of that array. So that is going to be the way I'm going to redim this. So instead of redimming it to 5, I'm going to redim it to however big the hotel array is. So that just says, give me the top index off the array, of that array, and put it here. So now I've made these now the same size. I figured out the first one, and the second one I'm saying make it the same size as the first one. So now I'm initializing my hotel array by putting in the names of hotels. What do I want to put in to initialize my route array? I'm just going to plop -1 into every place there. So now my route array looks like this. Like when this runs, my route array is going to be -1 all the way down. And I feel pretty good about getting those first 2 arrays initialized. Question? Oh, excellent. Thank you so much. Yeah, I'm not redimming the hotel, I'm redimming the route. And I declared the route here and redimming the route. Thank you. Can I like redim an array twice? Yeah, I can redim it as many times as I want. But here's the trick. Each time you redim it, it like blows the array away and allocates it somewhere else in memory. So, and in fact, it's pretty expensive to redim an array. From time to time, I'll see an example of a here's another approach to do it. Instead of redimming it up here, and this is one you'll see online quite a bit, is I'm just going to redim. Oh, this shouldn't be to 35. This also should be to the upper boundary of hotel. The whole point was we want to make this totally dynamic. So we could say, you know what, we're not quite sure how big we're going to need to make our route array. So just redim it to X and then write the value to X. So route sub X equals -1. This will work just fine. Well, it'll work fine. It's not just fine. It'll work fine. It's a fine solution. The problem is, well, actually, this won't work. With one more modification, this will work, sort of. The problem is when I redim an array, I literally blow the array away, and I'm making it again from scratch. What happened to the values that were already put into the array? Gone. But the good folks who are making VBA have anticipated this as well. And so when you redim it here, you can say redim preserve. If I say redim preserve, it sounds like you're saying, just make the array bigger and keep the old stuff there. It's not what happens. That's the end result. You get the array bigger with the same stuff in it. But what it does is it allocates memory somewhere else for the new array, however big you made it. And then one by one, it copies the old values into the new array, and then it frees up the old array. And so for 35, you wouldn't even notice how much longer this takes. But if you're loading something that's like 35,000 of these in, you will notice, because as that array gets bigger, it takes longer and longer to actually move those values across in memory. So It's kind of one of the hazards. You're just like looking something up on online and seeing, oh, that's how to do it. That's a really bad idea here. So instead of doing it that way, we're going to go back and do it this way. We're going to figure out how big to make it, rename it once, and then run through and do it. I'm going to print X, hotel X, and now route X. And we can see that's -1 for all of those. I could probably, since this is going to be a similar size, I'm going to put the route first and then the hotel. That'll just make that table a little bit easier to read. All right. Any questions? Okay. Next approach is we got one more array to do. We need to build this array. Distance is kind of a bad name for this array because that's the name of my worksheet. So let's just call this one dist. So far, the arrays that we've seen are what we refer to as one-dimension arrays. It's like just a vector of numbers, each with a vector of values, each with a number to tell me which one it is. But like for processing convenience, this array can be defined to be, even though however we build an array, it's always going to be start at this place in memory and a continuous stream of values. But we can organize it logically to say, well, don't think of it as one long line. Think of it as a grid. When I declare it, I can declare it with 2 indices instead of 1, and that will give me this. And that's exactly what it will do. So here's what I'm going to do. I'm going to create another variable, another array called dist. Oops, I don't want route to be a string. I want route to be, why don't I make it long? And we'll dim dist as, And the reason I'm making a route long is because these routes could get longer. I could imagine solving a problem with more than 32,000 stopping points in it. So I'm going to go to that next variable bigger. But what's the right data type for this one? So the dist, so when we talk about the type, it's the kind of data that's going to hold. Like what's the largest possible value between 2 locations on the Earth? Let's start with what's the circumference of the Earth? Hey, pretty good. Right between 24 and 25,000 miles. And by the way, so like how wide is a time zone? Like if you know the circumference of the Earth is 24,000 miles, how wide is a time zone at the equator? Yeah, I'm going to give you a clue here. There are 24 hours in a day. Yeah, they are, but on average, right? They're roughly 1,000 miles apart. Does that make sense for what you know here in America? Yeah, like 4 time zones, 4 different time zones, about 3,000 miles across. So yeah. So yeah, so if I have 2 locations and the distance between them is more than 24,000 miles, something's wrong. Like you're going the wrong way. Like you could go the wrong way. It would still be less than 24,000 miles to get there. So I think for this one, let's go ahead and make this one as an integer because that'll be 32,000. Let me hold the 32,000, and I can't have distances, at least on Earth, that are more than 32,000 miles apart from each other. Okay. And we're going to read this one. So here's the array that we have to build, but the data that we're working off of is this table right here. So let's start off just by reading in the first row. Let's get that going into our distance array, and then we'll build from there. So we can do that. And I think I want to separate this. This is going to be complex enough that I want to separate this and kind of make it its own loop that runs here. So it's going to be pretty similar to what we have right here. So for x equals 0 to the u bound of hotel, oh, I have to declare my variable. I got to redim my variable first. So this is going to be called dist. And I'm going to declare it to be like square. It's got 35 rows and 35 columns. Of course, in memory, it's one long continuous stream, but by giving it the two indices, it's saying, oh, you want to think of this as a grid. Great, we'll think of it as a grid. And now, to address this array, I've got to give it two values. And so whenever I refer to this array, I'll have to tell it, yeah, I'm talking about a particular row and a particular column. Does the row number come first or the column number come first? This will sound weird, but it doesn't matter. As long as you're consistent, it doesn't care if it's row first, column first, or column first, row first, as long as that's the way you always address it. Because remember, it's just a whole bunch of variables. Be consistent and it'll be fine. I tend to think of it as row first because that's the way you do ordered pairs in Excel. It's always row column when you're giving it two numbers. Okay, so in this one, instead of route, I'm going to say dist. Dist sub x. Now, I can't just give it one variable. I got to give it two. And so I'm going to go on the first row, and I'm going to go column by column. So I'm going to say 0. So on the 0th row and the xth column, I'm going to put whatever is in that location. So that would be right here. That's 0. In fact, I don't even need to read this one because what's going to be the default value in my whole array when it's created? Yeah, it's a numeric variables, and so they're all 0. So I'm not going to start at 0. I'm going to start at 1. And so when I'm on the 0th row, column number 1, I want to read something off of my distance sheet. And let me hard code the values in here to start with, and then we'll adjust them. But when I'm putting in that first one, I want to look on row number which? Row number 1, 2, column number 1, 2, 3. So row 2, column 3. That's the one that I want the first time through, but how do I express that such that it's fixed? Now, I'm making my row the same, so I am going to leave the row fixed for now, but how do I adjust my column? What should this expression be so that as this loop runs, it actually picks off a different column each time? Yeah, x plus 2. So x is going to be 1. We'll do x plus 2. X plus 2. So now I'm going to print x. I'll print the route, and then I will print my distance. Dist. Row number 0, column number x. And that should give me, as I'm printing off those hotels, it should give me 0 first, and then 691, 374, and so forth. Zero, 691, 374. It's pulling in that first set of values. Okay. So we've made this a little more complex by introducing what's referred to as a two-dimensional array. It means that because I've declared it with two indices, now every time I refer to it, I have to give it both indices. To say in the first indice, it's this one, second indice is this one. If you don't want to think about this as a grid, you could think about it as buckets, like 35 buckets, and inside every bucket is another bucket. So the first one says which of the big buckets to go through. Once you get to that bucket, go to the 35th bucket on the inside of that. Could I make an array with 3 dimensions? Yeah. So I could think of that as a cube, or I could say I've got the big buckets that have in it 35 small buckets, and inside each small bucket is 35 boxes. Could I do a 4th dimension? Yeah, it's hard to think of as one big array, but I could do 4 dimensions. The first number says which big bucket, second one says which small bucket, next one says which box inside that small bucket, and then the next one says I've got 35, I don't know, small boxes inside that box. So you can just kind of keep going in. So, but you just got to keep track of like how you're organizing those in your mind. After we can do 2, fine. 3 is a little harder. Once you get past 3, don't try to do it spatially. I think of it somewhere else. I remember one time, it was actually while I was a student, I'd already known about programming with arrays. I don't think it was VBA, no, because VBA wasn't even around when I was a student here. But I was like solving something for my marketing class, and I realized this is I need to make a 6-dimensional array, and it will do just what I need it to do. And it was like, but that's the only time I've ever done an array that's larger than 3 dimensions, like in that one class. I guess if I went into that field, I'd use it a lot more often. But anyway, you can make, you are limited only by the amount of available memory, like to the number of dimensions that you want, how big that they're going to be. So now you use up all of your available memory. Okay, so now we've got this that goes across that first row. We want this to happen 36 times. If I want this to happen 36 times, what should I do? Put this inside another loop. Yeah. Let me declare another variable up here. So I've got x, dim x as integer. Let me just dim y as integer. I don't know that x and y are the best names for these, but that's what I'm going to use. And now I'm just going to have a loop inside of a loop. Better kind of poke it in here. Oh, and again, not 35. Oh, that's my printing. I don't want to do the printing one. Sorry. Undo. This is the one that I want to duplicate. Okay, so my out one is going to be for y equals something. And next. Okay, so this now is going to happen. It's going to happen every single time. For y equals 1 to the upper bound of hotel. So the first time I go through, I'm going to want to start at column 3. Next time I go through, there's nothing for me to read over here. I'm going to start here. I like advancing which column I'm reading from by 1 each time. So I do have to go through all of these rows. So 1, better do that 0 to the upper boundary. That's going to get me to go to address every row in my 2-dimensional array. So now, instead of starting this at 1, what should I start this as? The first, when y is 0, this should be 1. When I'm on the 0 row, writing to my array, when I'm writing to the 0 row of the array, maybe I should go to the arrays. When I'm writing to the 0 row of the array, I want to write to the 1 column. When I'm on the 1 row of the array, I want to start on the 2 column. When I'm on the 2 row of the array, I want to start on the 3rd column. So what do I put here? Instead of starting at 1, I want to start at, yeah, when y is 0, I want this to be 1. And so now, instead of writing to the 0th row, I'm going to write to the yth row. And instead of writing to the reading from the 2nd row, I'm going to read from the yth plus 2 row. Sounds like we're done, but I think that's going to build that array. Let me put a stop right here. Oh, it's going to have half the array done. We'll run that, and let me just take a peek. What is dist sub 5, 6, 23? 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 23. So I've got that part built. We'll pick up next time by filling in the other part of this, and we'll solve the problem. Thanks for coming. Class dismissed.